Okay, good morning, pre-calculus class. So today we want to talk about 7.3. So 7.3 has a lot of material, so we'll divide into three different parts. So started with double angles identity. Okay. So 7.3 double angle formulas. So proof. Well, this one is something that is good to know. So let's say that we do have sine of A plus B. That's something we talked about last time, sum and difference. So once you expand it, so it's like this. So what happens if that B is the same as A? So we do have sine of A plus A, so sine of A, cosine of A, plus cosine A, sine A. Combine them together because those are the like terms. So this one, and also we can use the associative property of multiplication. So we swap that cosine A, sine A, and then since we do know that they're like terms, so we can combine them. So this one will be 2 sine A, cosine A. So then that'll be the proof. And double angle formula, so we do have sine 2A, so that equals 2 sine A, cosine A. Cosine of 2A, so that equals cosine square of A minus sine square of A. So that's the first form. The second form would be 2 cosine square of A minus 1. And then the third form, it's 1 minus sine square of A. So this one is something that you must know. Those are the main formula that you need to recognize. So double angle for tangent. So tangent of 2A, so 2 tangent A over 1 minus tangent square of A. So now let's do some examples. So let's start out with the first one. If sine A equals 3/5 with angle A in quadrant 2, find sine of 2A. So first thing that you want to do, so in order to use the new formula, we need cosine of A. So cosine of A can be found by using the Pythagorean theorem, or you can just simply draw the triangle in quadrant 2, so you figured out that the ratio for cosine of A is negative 4/5. But using that, the Pythagorean identity, also you can figure it out. So sine A, we do know that's 3/5. So subtract by plugging the number. So we got 1 minus 9 over 25, so we do have 16 over 25 plus minus, so we find out which sign to use. So since we do know that's in quadrant 2, so all students in calculus, cosine A in quadrant 2 is being negative. So it's going to be a negative ratio. Okay, so it's negative 4/5. And then after that, so we plug in that into the double angle formula for sine of 2A. So 2 sine A, cosine A. So we do have 2 times 3/5 times negative 4/5. So which is negative 24 over 25. So now here's another one. So sine of A, it's 1 over root 5. So you want to find out what cosine of 2A is. So first thing that you want to do, so you want to find out which form to use. So the one that's given is sine A, and we want to find out cosine of 2A. So we can use either one of those forms. But it's better for you to use the third form. The third form that involves with sine of A only. So expand it by plugging the number, the ratio. So 1 minus 2 times 1 over root 5, quantity squared, so it's 2 times 1/5. So which is 1 minus 2/5, so it's 3/5. So here's some of the examples that you guys can try to find out what you can do. Again, gotta be careful with the quadrants. So the quadrants, quadrant 3. So it doesn't mention about the quadrants, so that means it could be more than one solution. So check it out. Okay. So here's another one. So tangent of theta is negative 5 over 12 with theta in quadrant 4. Find sine of 2A. So tangent of theta is negative 5 over 12. So quadrant 4, so for cosine it's being positive, for sine is being negative. Using the Pythagorean theorem to find out what hypotenuse is, or x squared plus y squared equals r squared, so we got the hypotenuse, which is 13. And then using all the information, we find out cosine of theta, sine of theta, and then using the double angle identity, plug in a number, evaluate, multiply the fractions straight across. So we got negative 120 over 169. So for cosine of theta equals 1 over root 2 with theta in quadrant 1. Find tangent of 2A. So again, find out the missing element, find out what sine is. So sine For the value of y is 2, so tangent of theta is 2 over 1. And using that, the double angle identity of tangent, so 2 tangent A, all over 1 minus tangent square of A. Plug in a number, evaluate, so we got 4 over negative 3, or negative 4/3. So here's some of the following example you guys can try. Again, got to be careful with the quadrant, so whatever the quadrant that is, you need to point out the exact sign change. If that doesn't give you any angle, doesn't give you any quadrant, so that means it could be more than one solution. Okay, so this one's part 1 for the video. Okay, so I'll see you guys next time for second part of 7.3. All right, take care.